Hello guys, this is Joe Geek giving you another Java tutorial this 2020. We'll be using a gadget store use case. We'll be doing a simple add, edit, delete search, but a bit of additional features. This time we'll be using a Visual Studio Code as our IDE, mainly because it has lots of extensions and very lightweight. Let me open a terminal. Let me just create a directory that will be creating our project. Let's call it Java Projects. This will open a Visual Studio Code editor. So I recommend you to install this Spring Boot extension. This will install a bunch of features like initializer and all the other Spring Boot stuff. It makes it easier to create a Spring Boot project. Let me choose Java, and for the group ID we will be using com.jogeek.gadgetstore. For the project name or the artifact ID, we'll be using REST API. So we will choose 2.3.0 as a stable version of the Spring Boot. So for the dependencies, we will choose the basic Spring Boot DevTools. Also Spring Web, we will be creating a REST API example. As you can see, we have two main dependencies here, and we will just initialize the project. So I generated the project using the directory that I set up earlier. So in this project, I want to add also another dependency, which is Lombok. Just a bit overview of Lombok. It avoids having to write boilerplate codes, right? Like getter and setter. Also, I recommend you to watch my previous video about Project Lombok and how it will be easier to write model classes. Also, for this Lombok to work on VS Code, you need to install this extension. Also similar to how you use it in your Eclipse or IntelliJ. Now we have our project initialized. We can try to run and see if we don't have any issue with regards to libraries. As for Maven, it will automatically download all the dependencies you specified. As you can see here, it already runs fine, so we are good to go. Let's try to create another package. So creating package here is just simply creating a folder. Let's call this Web API. And we'll be creating here the main REST controller, which we will name as gadgetapi.java. So automatically here, when you say .java in the file name, it will create a Java file with a default codes like the public class declaration. So we'll annotate this as REST controller with a request mapping. Let's say store gadget. It's just a best practice to prefix your API with a meaningful name. Like for example, here we have store gadget, and let's say we create another REST controller, let's say store admin or store purchasing, those kind of best practice. As you can see here in Visual Studio Code, we also have the convenience of IntelliSense. Let's name this one is up. and this will just return a simple string saying it's okay. So normally when you have an API, it's good to have a dedicated API or a dedicated API call to see if your system is up or not, like a health check. We'll annotate this as get mapping / health. So now we can start this project and see if this simple API is working. So another convenient way of testing REST API here in Visual Studio Code is by using an extension called REST Client. So under test folder, we just need to create any file name contain HTTP requests. So just a reminder, this file will not be part of any code compilation. It will just a convenience way to record all our REST API URLs testing later. So again, testing REST API, we can use the browser, or in this case it's easier to test inside the IDE itself. So we just need to write the URL as if we're testing it from the browser. /store/gadget/health. Just highlight it and we'll just choose send request. Simple as that. So we can now test our REST client without using any browser. So again, a reminder to just install this kind of extension. So it's a REST client. It's similar to Postman. Instead, you will just be able to test your API directly from the IDE. So we'll just add some new information just to show you that the data will be changed properly. So just add new date that will show a timestamp on the health check. Let's just fix imports, java util.date. So now we can run it. And let's test the API again. So there you go, we can see the change already. So of course, putting a dummy URL will result in a 404 not found. So now let's try to create a model for this application. So we'll call the model as gadget.java. So here, using Lombok, we'll just annotate this class as @data. We'll also use @builder. So for gadget, let's say we have an ID, a serial number, a brand, a model, and a price. Okay, so from our API, For the purpose of demo, we'll just create a map of the classes. So let's create a new method called addGadget. We'll just pass three request params here: brand, model, and price. And it will create an object that will be installed in this map. So as you can see here, using the builder annotation from the Lombok, we can easily apply the builder pattern, which is a very convenient way of creating an object. It's very declarative and intuitive also. So here, for the serial number, we will generate a random 10-digit serial number. In that case, we'll be using Apache Commons Lang library. Okay, so after calling build method, we will just add this to the map. And we'll call this API as /add. So from the test, we'll supply the request parameters. So here we'll be using post HTTP method rather than put. So let me just correct that one. So now we're able to test. So by supplying the parameters and running the post command, it will return the object with the generated serial number. So just to see all the gadgets that's inside this dummy map collection, we'll create another API called getAll. And we'll just return the entries here. As you can see here in Spring Boot, we can also do test-driven development, which is very easy using Spring Boot test. As you can see here, using VS Code, we can easily run the unit test, whether run everything at once or just one by one. So it's very convenient and visual way to run your test. This is a part 1 of add, edit, delete in Java using Spring Boot and Visual Studio Code as editor. So please watch the part 2 and below.